Well, here we are. We're in section 10-2. I'm rocking a little Ludwig van Beethoven, Symphony Number 5 today. That's in C minor for those of you with a good ear. Hey, what we're talking about is using combinations in the binomial theorem. So this is going to be important stuff, statistical stuff that you're going to have to know, and some of it you might want to know. It's actually fairly interesting as far as if you like numbers and the lottery and all those things. This first word we come upon is a combination. And this is a selection of R objects from a group of N objects there where the order is not important. That's the major thing you got to know with combinations is order is not important. And you see I got a little rose drawn for us over here. My wife watches this silly show called The Bachelor. And on this silly show they give out roses. And when they give out these roses, when you get the rose, you know, if there's 10, 12 girls or whatever getting the rose, the order is not important. You don't care if you get the first one or the last one. The order doesn't matter. So the one thing you got to worry about on that show is all those roses have little thorns. And eventually those will come out. So look for the thorns in those roses. But the order does not matter. The Pascal's triangle was this very... it's kind of unique, but it's certainly interesting. It's this thing we're going to talk about later. It'll show us how to make those combinations, but essentially it goes 1 1 1 1 on the first row, and we call this the 0 row. The first row there, this one is called the 0 row, and then the second row is called the first row. It's kind of silly. And then we're going to go for the following row. It goes 1 2 1, and then 1 3 3 1, and that's Pascal's triangle. What's happening here is these two numbers, 1 and 2, add up to be 3, and so you can imagine that the next row is going to be 1 4 6 4 1. These two rows, and I'll show you why that's important. 1 and 3 is 4. I'll show you why that's important later. And then the binomial theorem is. You know, currently we know FOIL. So if we have something like x plus 2 squared, we could all say, oh, that's x plus 2 times x plus 2. Well, what if instead of it was x plus 2 squared, it was x plus 2 to the 8th power? What would we do with that? Well, that would be x plus 2 times x plus 2 times x plus 2 times x plus 2, 8 of them. We're gonna talk about how to do that and how exactly that whole thing works. And so let's proceed and see how that's going here. Combinations of n objects taken r at a time. So this is kind of how we talk about it. You can find this on your calculator under the math button, math and then probability. You'll see this NCR. You'll be able to use that. But this is what it does. Here's the math of the whole thing. So if we had 32 books and you want to pick 7 of them, and it didn't matter which order you picked them in. You see what it says here? It says, if the order of the books you choose is not important, not your favorite book first, or the book with a lot of pictures in it first, or less pages, just you pick 7 books. This is exactly how your calculator does the NCR. So it's 32 factorial over 25 factorial. That's 32 minus 7 times 7 factorial. And that ends up being 32 times 31. Remember, we already talked about what that factorial means. That 32, right? It's 32 over 25 times 7, right? So 29, 28, 27, 26, and then we're going to do a 25 factorial, not just because I'm running out of room there, but because on the bottom I'm going to have a 25 factorial that'll cross out. So I'm going to change colors here real quick. Those things will cross out. Okay, and then I have a times 7 factorial right there. And if you put all that in your calculator, you would get 3,365,856. And so we will talk about We'll talk more about that. All right. Here on the second page here, it says example 2, decide to multiply or add combinations. This can get kind of important. So in movie rentals, it says here, let's switch to something a little nicer than red. The local movie rental store is having a special on new releases. The new releases consist of 12 comedies, 8 actions, 7 dramas, 5 suspenses, and 9 family movies. You want exactly 2 comedies and 3 family movies. How many different movie combinations can you rent? Well, if you say I want 2 comedies and 3 family movies, then you really have to draw from the comedies and the family movies. And there were 12 comedies and there were 9 family movies. So I can take 2 out of the 12. So I have 12 factorial over 10 factorial times 2 factorial. And I take 3 out of the 9, which gives me 9 over 6 times 3. All right. That becomes 66 times 84. And again, you can, your calculator does this. Just type that in your calculator. Times 84 is 5544. Now again, this is, like we talked about the multiplication counting principle on the last section that we did, is very similar to that, because when we did that, we talked about multiplying, I have this set of choices for shirts and this set of choices for pants, and then we multiplied those 2 things together. So same thing here. I got the family movies and the comedies. Now the second one here is a little different. The second one here says you can rent 0, 1, or 2 movies. Because there are 41 movies total to choose from, the number of possible sets of movies. See, this isn't, there's an and an or situation. You're going to rent, on the first one it said, you're going to rent 12 comedies and 3 family movies. Here, word or. When we see and, I want you to think multiply. Okay? That's oftentimes how it works. Not always, but oftentimes. And when you see or, I want you to think add. All right? So when we could choose no movies. We go there, we've all done that before, looked for movies and couldn't find them. Nowadays, we go to the Red Box or whatever, but hey, you can't find any movies that look good. So you just forget it, I'm leaving. Or maybe you find 1 that you like, or maybe you find 2 that you like. And those are your 3 choices. So no movies, there's only 1 way to buy nothing. And there's 41 ways to buy 1 movie. You can buy the first one through the 41st one. If you do, this one's the only one you got to do the math on, and that ends up being 820. So there are 862 things you could do if you're going to rent 0, 1, or 2 movies. So that would be the answer there. And because of the or, we added. So that's important to know. You guys go ahead and do these ones here. Try to do them without a calculator. I know that's hard to say because a lot of you already picked up your calculator and it's probably done the first 3, but try to do 1 or 2 without a calculator. All right, welcome back. Hopefully you found this one was 35 and 20 and 12. Hopefully you got that. And this one was going to be 588. It said from example 2, find the number of possible movie combinations if you choose 2 action movies and 2 dramas. Now, remember, there were 8 actions and 7 dramas. So, if I wanted to do 8 choose 2 times 7 choose 2, it said and, right? And so I multiplied. That would equal 588. Good. All right. Next, we want to solve a multi-step problem. And so, obviously, when they say solve a multi-step problem, that's going to get a little more difficult, isn't it? A popular magazine has 11 articles. You want to read at least 2. Now, at least 2 conjures up an idea in my mind of an or. If your mom says to you, I want you to clean at least 2 rooms today. All right? At least means you got to do 2. Maybe you could do more than 2. You could do 3. You could do all 11, but you got to do at least 2. So for each of the 11 articles, you can choose to read or not read the article. So there are 2 to the 11 total combinations of things you could do. Read yes or no on each one, right? That's 2 different things you could do 11 times. Each time you look at an article, you can say yes or you can say no. If you read at least 2 articles, you do not read only a total of 0 or 1. Those are the things you can't do. So if you came home, if Mom came home and said, I told you to clean 2 rooms, you said, well, no, I only cleaned 1. No, at least 2. You had to do at least 2. The number of ways you can read at least 2 articles would then be 2 to the 11th minus the chances of reading no articles or the chance of reading just 1 article. So 2 to the 11th, 2,048, minus 1 plus 11. This would be 1 way to do nothing. There would be 11 ways to do all of them. So minus 1 plus 11, so that's 12. And you get 2,036 different ways. That's pretty tough, isn't it? That is not easy at all. You go ahead and read this one here, your high school football team. And let's kind of walk through this together. You kind of answer some of my questions as we go, and we'll work together. Your high school football team has 10 scheduled games for the season. You want to attend at least 4. That means what can you not do? Right, 0, 1, 2, or 3. You can't do that. So, and you have a choice to attend all of them, right? So you can do 2 to the 10th every game. That's 1,024 different things you could do. Let's write that over here, 1,024 different things you can do. But what you can't do, you got to take away the possibility of doing no games, right? The possibility of doing 1 game, the possibility of doing 2 games, or the possibility of just going to 3 games. That's not possible. You can't do that. And so if I put all that together in my calculator, I hope you ended up with 848 if you just did all the math on that. Okay? All right, this is that cool thing I was telling you about, Pascal's triangle. Now, Pascal's triangle, when we talk about the 0th row, right on the top, it's 0, choose 0. 0, choose 0 is 1 in your calculator. You'll see that. Pascal's triangle is going to be very beneficial to us in a lot of different ways, but this is how originally they memorized how to choose all these things. And so they had, all of these are 1, choose 0, 2, choose 0. And when you talk about how many different ways can I choose 0 things, that's always 1. There's only 1 way to choose 0 things. And on the right side, it's 1, choose 1, 2, choose 2, 3, choose 3. There's only 1 way to choose everything. Okay? It's the stuff in the middle that they struggle with. So how many different ways can you choose two things? Yeah, or, one of the 2 things? Well, that was 2. That one was simple. Okay? And I could choose 3, choose 1, or 3, choose 2. Well, those were 3 and 3. Those were simple also. The next row was where it started to get a little more difficult, and they really kind of used it. Now, what's happening here is we'd have 1 on the outside always, and then you add these 2 things together, and you add these 2 things together, and you get the 1 and the 3 made a 4, and the 1 and the 3 made a 4, and the 3 and the 3 made a 6. Okay? But as it went, it got very, very long. Okay, so obviously it went 1, 5, 10, 10, 5, and 1, and so on and so forth. All right, so let's see how that helps. All right, we're going to use Pascal's triangle. So the class representatives, out of 5 finalists, your class must choose 3 class representatives. Does it matter in what order we choose them? Like the most popular kid and second one? Doesn't matter. Order here does not matter. All right? So when order doesn't matter, we want to do 5, choose 3. And we're going to use the Pascal's triangle, the 5th row of the Pascal's triangle, to find that for us. So remember what the rows were. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. All right? This is the 0 row. 1, 2. So the third row right here, fourth row, and right here is my fifth row. Okay? So I had 1, choose 1, or 5, choose 1, 5, choose, I'm sorry, that first one should be 5, choose 0, 5, choose 1, 2, 3, 4, and 5. 1's on the outsides, always. The number of the row is the next one in. All right? And then we have 10 and 10. Okay? That's the fifth row of Pascal's triangle. The value of 5, choose 3 is the fourth value in the row. It's this one right here. All right? Fourth value in the row, Pascal's triangle. Therefore, 5, choose 3 equals 10. There are 10 different ways that you can choose 3 representatives for your class. You guys go ahead and do example 6. All right, hopefully you pause that. Welcome back. I hope when you use Pascal's triangle to find the number of combinations of 3 students that can be chosen from 8 finalists, that's 8, choose 3. I hope you guys all got 56. And maybe you used your calculator and maybe you used Pascal's triangle. Probably doesn't matter a whole lot. All right, this is the tough stuff right here. Binomial theorem. This is the stuff we've been waiting for. This is the stuff that is going to help you to get to the next level in math class for sure. A plus B to the n, and it's this whole thing, and it looks like a lot of stuff, and it probably is a lot of stuff. So let's take a look at it. The first term there in n, so let's say this is to like the 8th power, that first term is going to be 8, choose 0, then 8, choose 1, and then 8, and those are the coefficients. Okay? So let's see how this plays out for this next one. Let's do x plus 4 to the 3rd power. Now, x plus 4 to the 3rd power, we all know means x plus 4 times x plus 4 times x plus 4. And some of you are saying, well, Mr. Wright, why don't I just FOIL the first two and then multiply everything out together? You can do that. It's just when we get to the 8th power, this is going to make your life easier. So we have an n of 3. So our first thing is going to be 3, choose 0. All right? And then we have x to the 3rd power and 4 to the 0 power. These two numbers, 3 and 0, will always add up to 3. Okay? And this 0 right here will go with this 0 right here. Those things will always go together. Okay? So the next one, we're going to do a plus. The next one is going to be 3, choose 1. That's the next term. X is now going to be to the 2nd power, and 4 is going to be to the 1st power. Now remember, like I said before, this 1 and this 1 will go together. And this 2 and the 1 will add up to be 3. Okay? Plus 3, choose 2. X to the 1st power, 4 to the 2nd power. See my 2's matched up again? And the last one would be 3, choose 3. Give myself a little room. 3, choose 3. X to the 0 power. See, this was x to the 1. X to the 0, 4 to the 3rd. Okay, so then we have all of those, then we have to do all the work on them. So let's take a look at what the work would be. I'm going to change my color here so we know we're transitioning. 3, 0 is 1 times x to the 3rd, 4 to the 0 is 1. So I just have x to the 3rd for that one. Plus, and some of you are saying, duh, I knew that. I could have guessed that one. Oh yeah, sure. Plus 3 times x squared times 4. Well, 3 times 4 is 12. 12x squared is the 2nd term. A little harder to get to on that one. And 3, choose 2 there, 3 combination 2, is 3 times x times 16. That's 48. X plus 3, choose 3, 1 times x to the 0 is 1, and 4 to the 3rd is 64. So it's going to end in 64. Or really it ends in 4 to the third. And it starts in x to the third. So when we look at those two things, those kind of make sense to us. But that's how you do that. That's kind of tough stuff. Let's take a look at this last page. There's a lot of things for you to do on this last page. And 2m minus n to the fourth power is, it's important that you note that that's a negative n in there. If that says minus n, I would always make that plus negative n. That's going to help you to not, it's really going to help you to avoid mistakes, because you're going to make some mistakes with this stuff from time to time. My key number here is 4. My key number is 4. So I'm going to do 4, choose 0, 2m, and I'm going to put parentheses around my 2m to the fourth power, and then negative n, put parentheses around my negative n to the 0 power, plus 4 combination 1, 2m to the third power. This number is going to go down, 4, 3, 2, 1, 0, while this other number goes up, 0, 1, 2, 3, 4. That's why they always add up to the number 4. 1 plus 3 is 4. Okay? Plus 4. I hope you guys are seeing this pattern. There's really no easy way to do this. You have to do this all by hand. I wish there was like something you had in your calculator, and you know what? Probably somebody will invent that soon. By the time your kids are there, they'll never have to do this. But 2m to the second, negative n to the second. All right? Plus 4 combination 3, 2m to the 1 now, and negative n to the third. And then the last one, plus, and I'm just going to put mine down here, 4, choose 4, 2m, I'm sorry, this 1 here should have been on the inside of that parentheses, 2m to the 0, and negative n to the fourth. Okay? And then you do all the math that's involved in that. So there's a little bit of math there. On the first one, we have a 1 times, 1 times, 2 to the fourth is 16, m to the fourth, and n to the 0 is just 1. So that first term is going to be 16 m to the fourth power plus 4 times 2 to the third power is 8, m to the third, and negative n to the 1 is negative n. Well, what that negative n does is 4 times 8 is 32, but there's going to be a negative 32, because that's a negative number. M to the third, n to the first, plus 4, choose 2. Now, 4 choose 2 is going to be, if we remember our Pascal's triangle, we had 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, right? 0, 1, 2. So that's going to be a 6. Right here is 6 times 2 squared is 4, m squared, negative n squared. Well, the negative gets squared, so it's positive, so it just becomes n squared. So I have 24 m squared, n squared. All right? Plus 4 choose 3. That's right here. That's a 4. Okay? So look, I got a 1, a 4, a 6, a 4, a 1 coming back down, right? So on this one, just looking for somewhere I'm going to write. I'm gonna write up here if you guys don't mind. I'm gonna change colors so you kind of know that I'm moving here. Those of you who aren't paying attention, I'm gonna right up here. I'm gonna finish this, and I'm on the 4 choose 3 right now. I'm on this one. Okay, so 4 choose 3 was 4. Nope, I don't know what that says there. 4 choose 3 is 4. 2m to the first, so times 2m. Negative n to the third is going to give me a negative n cubed. And so that negative is going to go to the 4. 4 times 2 is 8, so I'm going to have a negative 8 m n to the third. That's a negative, or a minus, okay? And then my last one, I'll change colors one more time to keep you guys, sorry for all the messiness, they don't give me enough room here to write. And then we're going to do this one right here. 4, choose 4 is 1. So this is plus 1. 2m to the 0 is 1 times 1. And negative n to the fourth is going to be just n to the fourth because the negative to the fourth, the negatives erase. So it stops with plus n to the fourth. And so my final answer ends up being in this hideous, hideous burnt orange color. This thing right here. Okay? Tough, tough stuff. Now, those aren't the kind of questions they're generally going to ask you on a test. The kinds of things they're going to ask on a test are like example number 7 here. So let's change back to a better looking color. In fact, let's just go back to black. All right. Find the coefficient of x to the 5th in this expansion. So what they're looking to do here is they're just saying, hey, you don't have to find everything. You just have to find that 5th term. And if you can find that 5th term, then you're going to be all set. So what's r going to be when x is to the 5th? Well, we got to think about that for a little bit. If x is to the 5th, that means I had 2x quantity to the 5th. And I had negative 7 quantity to the, well, 5 plus 4 is 9 to the 4th. And then my c over here started with a 9. 9 choose what? 9 choose 4. So that's how you're going to find that. You're going to start right away with the 5th. And if you put all that together, what they ask you for is the coefficient. That's the number. So you got 9 choose 4, which is 126. And you got 2 to the 5th, which is 32. And you got negative 7 to the 4th, which is 2401. And if you multiply those three numbers together, you end up with, now watch this crazy number, 9,680,832. That's how we get those. All right? You guys go ahead and take a look at these checkpoints here. All right, welcome back. I hope you were able to get a to the 3rd plus 6a squared b plus 12ab squared. That was supposed to be a plus sign, wasn't it? Plus 12ab squared plus 8b cubed. I hope you're able to follow all the steps and do that. This next one was 1296 minus, you see how they switched the 6 and the s around there, didn't they? 1296 minus 864s plus 216s squared minus 24s to the 3rd plus s to the 4th. Notice the ones that are minus are the ones with the odd powers. That's going to come in handy. And then number 9, this is the kind of question you're going to get on the test. 1,180,980. And I hope when you were looking for number 8 there, you started with 3x quantity. Quantity is important because that's going to be 3 to the 8th, negative 2 to the 2nd, and 10 choose 8. I hope you're able to do that. All right. Sorry for the long lesson today, guys. I'll try to do a better job next time. Thank you.